Welcome to this chapter. You will learn how to design and manage jobs in Talon Studio. You will create jobs, generate sample data, work with files, connect to databases, enrich data, and install missing libraries. Let's generate random data. This helps you build and test pipelines even when real data is not yet available. It also helps you mask sensitive data by replacing it with realistic values. It helps you produce controlled data sets for testing. Here are some of the components in creating random data in Talon. Use T-Row Generator to produce rows and fields with random values. This creates a simple input flow for testing. Connect it to the T-Log-Row to display your results in the Run console. This lets you check if the data looks correct before you build more logic. Let's head to the Talon Studio for some demo. Start with creating jobs in Talon Studio. You may go along with this demo to familiarize yourself with Talon Studio. Open the project that we previously created. Go to the repository panel. Right-click Job Designs. Select Create Standard Job. Enter a name, a purpose, and a short description. This helps you identify the job later. Open the palette and drag components into the designer. Place them in the order you want the flow to run. You may use the search field in the palette to search for T-Row Generator. Drag the component into the designer, then double-click to open the properties. Click the Add button to add the columns that you will be generating. Name your columns properly. Here, we have a column for the functions. It is a drop-down of predefined functions that we can use for the data generation. We'll be generating random names. One column for the first name and another column for the last name. Both will be of string type. In the Functions field, select Talon Data Generator Get First Name for the first name column, and Talon Data Generator Get Last Name for the last name column. Let's add another component, T-Log-Row, to check the output. Search for T-Log-Row in the search field and drag the component into the designer. Create a flow by right-clicking the T-Row generator, hovering over row, selecting main and clicking T-Log-Row. Head over to the component view and click Sync Columns. This keeps the T-Log-Row schema aligned with the incoming metadata. For the mode, select the second option for a readable output. Open the Run tab and click Run. These are the generated rows. Now work with files. Many integrations still rely on CSV, Excel, XML, JSON, Avro, and Parquet. You might also handle folders with multiple files. Use the iFileInput delimited and its related components to read a file row by row. The component splits a row into fields based on the schema you set. Use the iFileOutput delimited to write data to a new file. Define the schema and choose the output location. Use the iFileList when you need to process many files in one folder. This gives you a loop that reads each file one at a time. Let's go back to the Talon Studio and create another job. Enter a name, a purpose, and a short description. In the palette, under the file family, expand input, and drag and drop T-file input delimited into the design workspace. Open your CSV file by clicking the ellipses button beside the file name /stream section in the component view. Save the properties to the metadata. Add the property name, purpose, and description. This helps you identify the file in future use. Click Next. Since the file is comma delimited, select comma for the field separator. For the escape character, select the double quotation mark. Set heading row as column names and select Refresh Preview to update the preview window. Click Next. You now see the schema. Review the type, length, and precision of each fields. Change the length of item description column to 255. Save the schema to the metadata. Input name and click Finish. To view the data, add T-log row. You can also search for directly in the design workspace. Click an empty area and type T-log row. In the component view, select the second option. Click Sync Columns. Open the Run tab and click Run. Now, output the data into a CSV file. Add another component, TMAP. We will be explaining about TMAP in the Enriching Data section of this chapter. Double-click the TMAP component. Select all columns in left part. This represents the input. Click the plus button at the upper right to create the output. Drag all columns from the input to the output. Review the schema of the columns. To confirm the consistency of the input and the output, click Apply, then OK. Add T-file output delimited to output the map data into CSV. Right-click TMAP, hover over row, and select Out 1. Click in the blank space and type T-file output delimited. Double-click it and open the component view. If you wish to change the field separator, you may do so here. For this demo, keep the semicolon separator. Click Sync Column to align the schema from source to output. In the advanced settings, disable the option that throws an error when the file already exists. Open the Run tab and click Run. You'll notice an error in the run. The error comes from incompatible data types from the source to the output. We will leave the error for now and revisit it in the Enriching Data section. Next, output all the data that caused the error. Right-click T-file input delimited and select Reject. Type TMAP and map all the columns from the source to the output. Name the output schema Reject. Save and apply changes. Right-click the second TMAP and select Reject. Click and type T-log row to output the rejects. Set the mode to table to make it readable. Click Sync Columns and run the job again. A closer look at the error shows that string values are being sent to item code, which expects an integer. We will revisit this error in the next topic when we enrich and validate the data. Connect with databases when you need to extract or migrate data. Use TDB connection to open a database session such as MySQL or PostgreSQL. Use TDB input to read data based on the schema. Use TDB output to write rows into a table. Use TDB row to execute custom SQL such as insert statements or update statements. Control transactions with TDB commit and TDB rollback. Close the session with TDB close once the flow ends. Let's connect to a database. Create another job. Add the property name, purpose, and description. We can create a connection through the metadata. As explained previously, metadata is where database connections, file schemas, and service definitions sit. Expand metadata, right-click DB connections, and create connection. These are the catalog of available DB connections. We can connect to access Amazon Aurora, Amazon Redshift, big data platforms like Hive. We also have MySQL, PostgreSQL, SAP HANA. For this demo, we'll be connecting to SAP HANA. Input the connection name, purpose, and description. This helps you identify the connection in future use. Input the connection details and user credentials. Some features or component needs jar files to run. These are the dependencies that we need to install before running the job. The pop-up window prompts to install the missing jar library. Missing libraries may be automatically fetched internally, but there are instances that you need to install external jar libraries. Here, while running SAP HANA DB, it prompted a window to install ngDBC. The jar file was downloaded externally. Locate the jar file and click Install. We have successfully connected and created DB connection to SAP HANA. In this sample job, we'll go through the components used and the flow of the job. Let's start with the pre-job. Pre-job and post-job are special sections in a Talend job that let you run steps before and after the main flow. Usually, pre-jobs contain the connection, while the post-job contains the closing of the connection. Here, we have the pre-job to initiate connection to SAP HANA DB. These are the connection details from the connection that we created previously. The TDB input queries the database and output it using tlog row. In this example, we are querying data from a custom table Z, EC, C2, S4. And in the post job, we are closing our connection to SAP HANA. Let's run the job. The output is expected as this table is empty, but we can still see the columns from the table.